Okay, so I think we're live. Go ahead and re-up the stream. And while I'm at it, I'm just gonna pull another browser over here. Okay. Well, it looks like this is working. All right, so we'll wait for a few minutes for people to drop in. I think in the meantime, we'll go ahead and pull up some of the things that we will be using for this stream. All right, it's going to be fun. I've got a lot of terminals here. Um, oops. And I'm going to go ahead and exit out of some of this stuff so that we can demonstrate it from scratch. So perhaps what I'll do is clear. All right, give me a second to pull up the chat again here. And then I think we can probably get started in like 2 minutes. Okay, cool. Just set up comments. Actually, just looking for a way to change the way that my horizontal, or my vertical stream looks. We'll worry about that on another stream. All right, so I think we can probably get started. So I'll introduce Parallax a little bit. So this is a new tool by Gradient Network. I first learned about this on Twitter through Ahmed Osman's page. Let me see if I can find him. So definitely go check out his page. He's hosting this challenge along with Asuka Red Panda. Um, can I find the actual post here? So this is the challenge here, and that is why we're doing this tonight. Because we have about 6 hours left before the deadline for this, and this is my submission for the challenge. So I figured I would go through how to set it up, how to set up Gradient just on its own from the stock standard repo, and then how to set it up using MyFork, um, which mostly does not differ in any functional way, except for the way that I actually install the package. Just makes it a little bit more ergonomic. Okay, so first thing is I'm going to want to clone Parallax. So see if I can demonstrate this here. Will this work? I think it should. So what I would start out, or what I have started out doing, is using the GitHub CLI just to log in on uh, my virtual machine. So pretty stock standard stuff. Uh, you would install the GitHub CLI, log in here. It will take you back to your terminal after you're done. I can exit that one. So we won't go through this entire flow here, but this is just how you would start that out. If I wanted to figure out how to install the GitHub CLI, let's see, this is Ubuntu. So you can just Google it. Will bring you to this page. They have precompiled binaries, and then I would just click on the Debian link here. So this is going to make it a little bit easier to just set up my connection to GitHub on a VM that I don't normally use for development, but I do need it for working on CUDA software. So go ahead and gh repo clone. We'll call this stock Parallax. And so I believe I need gradient HQ slash Parallax. I'm gonna double check the repo name. Okay. Cool. So we cloned it into the stock Parallax folder here by ls. I can see that we have everything we need. So if I scroll down to the installation guide, it's pretty straightforward. Describes the step that I already followed here. So now all I have to do is install it, which means switching between keyboard layers so that I can select this. See if this just works right off the bat. Okay, so yeah, right off the bat, I don't have pip on my path. That's probably because I don't have a PyEnv installation. So I'm going to UV Python install 3.12. Okay, so I need to UV Python update shell. And actually don't remember exactly what command I need to refresh my shell. Okay, don't remember off the top of my head what that command is in Ubuntu, but that's okay. Oops. And again, this is what happens when you use a Mac keyboard layout on your they had to bind that to the Mac layout just to make this as horrible as possible. And of course, the visual cursor doesn't actually line up with where the cursor is. Okay. Horrendous software. Okay. My mouse actually just does not work. So we're going to try that one more time. All right. Okay. Excellent. So I was able to do that using my other monitor. Okay. Just have to be mindful to literally never press the Windows key, or rather what should be the Mac key, the command key. Okay. Try this one more time. That's better. Okay. So I'm going to open a new tab here. And now we should have okay. Right, so I need to UV Python probably set my default. Okay, I'm used to using poetry for this. So let me just quickly default flag, and then pinning the global. Okay, so right. Okay, there we go. So now if I do pip install dash e dot GPU, UV doesn't install the. Okay, well, I do have UV, so I'm just going to make this easy for myself and UV pip install dash E. And that should select the right version of. So already you can kind of see some of the pains of trying to use Python on a fresh system without installing something like Poetry or Pyenv. So, oops, wrong flag, global, oh, not global, system. Does it want that after install? Okay. Externally managed. So it's going to want. All right, so we'll do this. The hmm, the easy way? Question mark. So essentially, the difficulty that I found with this was actually this workflow right here. I'm going to go ahead and demonstrate for a moment. What happens if we use, excuse me, what happens if we use UV for this instead of using, oh, we did it again. This is so profoundly bad. Okay. Once more. Microsoft is actually the bane of my existence with this. Okay. I thought it would be fun to show that this does indeed work on WSL, but you are probably better off installing Linux. Oh my goodness. Wow. Okay. Let me see if I can. Oh, yeah. So I did this on my laptop where I already have PyEnv set up. It's pretty easy. Um, that's not going to work as easily on my desktop. So that's why I switched to using UV. Okay, we are back. So just waiting for things to start up. Cool. There we go. Okay, so let's demonstrate this. We're going to, don't use your gaming computer for demos. We're going to UV sync. That's going to lock all of my packages. I actually need to, let's see, install xglang. Okay, so now we have all of the packages we need installed, and I can UV run Parallax run. This is going to start our server here. And if I open a new tab and do something like okay. We'll use my laptop as the host for this. So come back here and do the same thing, UV parallax, UV run, parallax, run. So that will make that port accessible from my machine here. And if we come back over here, we get this nice little user interface for starting up the cluster. We can pick a model of our choosing, and it gives us this helpful little notice about how much VRAM we'll need to actually run that model. So I'm going to pick one that I know works, which is the Quen 3 8 billion parameter model. Um, actually, I believe this one does work. We're going to try it with the 4 billion parameter model. Let's see. Okay. We're going to try it with the 4 billion parameter model first. And this I know will definitely work. So we hit start. Oh, that was actually WSL crashing. Okay. Again, don't use your gaming computer for this. Um, I mean, you can and certainly do, but you will have to contend with Windows and all the fun things it likes to do whenever I do a demo. You can really tell it's a demo today. Go ahead and close those windows. That's unique. All right, we're going to restart this node. I don't know how VirtualBox got on my node. So let's try this out with just my MacBook for now. So dead simple. UV run, Parallax join. And we can see it start up. So if I'm lucky enough, this might start with just one node, but because I picked two at the very beginning, it might want to wait until the second node comes up. And I happen to know that the M3 MacBook Pro has just enough memory to run this. So if my other node doesn't come up immediately, we'll go ahead and shut this down. And just restart it. Okay, so now that's waiting for the server to start up here. And it starts up right away. So one of the neat features about this is that we can just start this up on its own for now with just the MacBook M3. And once it finishes downloading there we go. So once it finishes downloading and loading up the model, should drop us exactly right into the chat. And we can start asking our LLM questions. And as our exceptionally behaved Windows node comes back up, okay, now we're hitting the page file. I might freeze for a moment. So apologies if the video is choppy, but I think it's actually going to be a useful demonstration of, okay. And now the system is responding again. So that's kind of a good demonstration of sort of what's possible with a local LLM. But you can see that that was not very easy on my system. You can see we got, it might be hard to see, but that's 2.19 tokens per second. Not great. So let me go ahead and I'm actually going to shut this down. And then I'm going to start it back up. And this time I'm going to put the CUDA node as the first node in the pipeline, and the Mac node as the second node. Hopefully they arrange themselves in that order, but that should allow the MacBook to have to load much less of the model into memory. So it will select part of the layers instead of the entire set. Um, let's go ahead and try that now. So let's see. Okay, so there we go. Oh, right. We actually have to first select our model. So let's do the same model. 12 gigabytes of RAM required. Yeah. And the NVIDIA node just shows right up. Let me go ahead and check the comments. I haven't seen any, but I'm kind of new to using the platform that I'm using. So apologies if I've missed anyone's comments. Okay, so now you can see that these are both starting up. If I pull up the yeah, so now you can see the NVIDIA node is loading part of the model first. Oh, okay. It actually started up so fast because it already has that model downloaded. Um, so let me see if I can clear this. All right. Let's try this again, see what we can get for tokens per second. So for me, my MacBook is at least still responding, which is a lot better than what we were getting before. Um, I have found that in general, the time to first token on my systems is not the best. Okay, we got a little bit faster that time. Um, now I'm gonna see if there's anything that's especially hard on my system memory right now, because that obviously makes an enormous difference in your ability to use these tools. Um, and of course, I do find that Rust Analyzer is using 7 GB of memory. Um, give me a moment here. I'm gonna exit out of this. Also going to close a lot of browser tabs. Definitely, one of the keys to being able to do this is not having Firefox consuming 12 GB of memory. Um, okay, so that freed up quite a bit of memory. Let's try that again. Don't think our model liked that one. Oh dear. All right, let's try that again. But as you can see, we're able to get much faster output. Okay, one moment. I'm going to close some more Visual Studio windows and free up a little bit more memory. Okay, cool. So, as you can see, still not getting an incredibly fast token rate, but yeah, we've freed up quite a bit of memory. Um, so to be honest, I have not really tested this while streaming, and while using remote desktop at the same time. So that's definitely having an impact. Um, Let me try this one more time. And then I want to see if I can have my Mac node drop out and have it rebalance the model just to my CUDA node. Let me also get the CPU histogram up here. This might be kind of interesting. Is you can see this thing just um, absolutely decimating the CPU cores. And uh, in spite of that, you will notice that my system CPU usage is not that high. Uh, I suspect that the reason for this is once this query finishes, these cores will probably calm down. But I could be wrong about that. Just a hypothesis. Wow, this is pretty hard on my system. Okay, we are going to kill this and try again, but this time with just the CUDA node. I suspect that I just do not have the system memory to support streaming uh, and doing LLM inference at the same time on this machine. I was able to get about 40 tokens per second, actually, so about 20 times what we're getting now. Um, so let me, the 4 billion model. Oh, interesting. It's been having some issues. Yeah, I think transcoding is actually what's using all of that right now. So normally what I would see is this spiking to almost 100% while requests are in flight. And then it would come back down pretty much immediately after. Um, but yeah, um, the app that I'm using, maybe it's using software encoding. Um, Hopefully on the next stream, we'll be able to try again with OBS and some multi-streaming setup, and that might work better. Okay, so let's see if this works any better. Did something go wrong? No, it's just joining. Okay, that looks almost ready. Okay, let's see what kind of performance we can. Hmm, tokens per second, 86. Yeah, so as you can see, my map was actually the thing bogging down that pipeline because of the transcoding. Um, but I'm able to essentially still host this across two different nodes. Um, let's see what happens if we use Parallax join now. It does make sense that that would slow it down. You know, we only have kind of this much headroom on these cores for inference. So also it has to load, you know, at least part of a 12 gigabyte model into memory. Not terribly efficient. Okay. So we'll see if that speeds it up at all or just causes us to run into the page file again. Um, okay, so as you can see now, we are getting 120 tokens per second. Let's clear this, just see if we get, oh, did we load the wrong model? I think we might have. We reload. So when I first tried this, live model reloading was not working yet. That's pretty cool. Sometime in the next week or two, I want to show you something that I've been working on. I think we're getting towards the end of the stream now. I'll probably end it in the next 10 minutes or so. But so I've been working on an inference engine of, well, not an inference engine of my own, but an orchestrator for it, similar to how Parallax works, by essentially having these separate instances of the inference engine and then orchestrating the activation transfer between them. You can put them in a pipeline parallel mode where each node only needs part of the model loaded. So that's basically how we're able to load models that are larger than either node's memory. Um, and let's go ahead and try it. Maybe we'll get something better than 2 tokens per second. If we don't, maybe I'll switch to. Oh yeah, that looks like some improvement at least, and you can see these other cores are starting to really ramp up. So you can kind of imagine what would be happening if we had more headroom in the system for both memory and CPU. And now we're getting almost twice the tokens per second. Um, if we go down to a 1.7 billion parameter model, um, I suspect this will be the one that we get about 40 tokens per second with, and then probably closer to about 80 tokens per second when we combine the two machines. Go ahead and re-up this on Twitter. I really kind of fumbled the first part of that, the demonstration. I You can see why I do not use pip, why it was literally the first thing I did before I was able to get Parallax running. I decided to swap pip out for UV and Mies. So you probably saw me use Mies install -sglang. That's basically like as long as you have Mies installed on your system, that's sort of like one command to set the entire thing up. And then you just UV run, parallax run, and you drop into this. Okay, so let's try that again. Fascinating. Um, so if you know how LLMs work, you will know that this is completely non-deterministic. It is stochastic. Um, I just find it interesting when it either makes up something or starts repeating some training data like Leela. Whereas other times, let's see, I'll have my Mac node just drop out. So we got about 8 tokens per second there with the Mac. Good Lord. All right, so the Mac is the bottleneck, as you can see. Using it strictly tanks my inference speed. Okay, that's better. That almost seems like it was additive. Now it's no longer Leela, it's back to being Gwen. Reliable machines that these are. So yeah, you can see our tokens per second, super, super inconsistent, most likely due to me streaming. So I think next time we're going to come back with hopefully more of this on another machine. If we're lucky, we might even have an M4 to kind of subsume a lot of the processing that's needing to be done on my MacBook. Um, so yeah, having something like an M4 Mac Mini and the RTX 4070 might give us a little bit more of a sort of like fair pipeline. Um, yeah, and then when we come back, likely next week, I will also show off the tool that I've built that's inspired by Parallax and some of the infrastructure as code tooling that I've been working on, which I'm especially excited about. It's a culmination of uh, all of the infrastructure as code ideas and just libraries that I've been working on for about the last year and a half. So I hope you're as excited as I am to join me for that. And thank you for being here for this. Yeah, I hope everybody learned something. I know I did. Okay, thanks and have a great evening, everyone.